Now see a refraction of plane wavefront by prism, by lens and by concave mirror. Suppose first we take a prism. The prism is like this, that is a triangular base I have taken. This is A, B and C. Suppose a plane wavefront incident over here, that is your P and Q. So rays are like this. After refraction, here the rays fall over here and it gets refracted in this way, and the refracted plane wavefront is obtained like that, P dash Q dash. If you have taken a convex lens like this, you have taken these are the parallel rays. So, the plane wavefront P and Q is like this. This incident on this lens and this lens refract all these rays and converge at this point. So, the plane wavefront here now become converging wavefront. So, when the plane wavefront strike on a convex lens, it gives us a converging wavefront. Now, we can take the incidence of the plane wavefront on a concave mirror also. So, suppose you have taken a concave mirror like this, and this one, these are the parallel rays I am taking here, that is actually a P and Q, a plane wavefront. So, these rays are taken here. After reflection, all these rays passes through a focus, and now this has converted into here the converging wavefront. So, it was actually a plane wavefront, now it has become here the converging wavefront. So, here the refraction of the plane wavefront by using prism, lens and concave mirror, you can also draw like these shapes for the different lenses or the mirrors. Now, see here superposition principle. It is very important principle here. By using this principle, we can get the resultant displacement or the the intensity of the light at any point. Now, see, suppose there are two waves traveling in the same direction like this and having the different displacement at any time t. Suppose this is the displacement for the first one, for the second one this is the displacement y2, and this side I have taken as a y. So, when these two waves superimpose on each other in a medium, at any point the resultant displacement is equal to the vector sum of the individual waves at that time. So, we can write y is equal to y1 plus y2, and if there are the number of waves we can write here by dot. So, the net displacement at any point is equal to the vector sum of the displacement of the individual waves at that time. This is actually the principle of superposition.